Okay, right here, we're going to be looking at a simple chemical substance being formed by plants. This is known as glucose, this simple sugar is known as glucose. That's the first example you're going to be looking at. Now, every plant undergoes this. Every plant with chlorophyll undergoes this. As you can see, carbon dioxide reacts with water to bring about the production of glucose, C6H12O6, and oxygen as a byproduct. Now, this perfectly explains the first law we're talking about, the law of conservation of matter. And also, we could relate this with the various productions of drugs and the rest, different substances. So when you look at this, glucose is being produced after the reaction between carbon dioxide and water, and we end up having oxygen also as a byproduct. So first of all, let's balance this very chemical equation. We're going to be looking at that, how to balance chemical equation in our next couple of lessons. So here we have carbon, just one atom of carbon. We have 6 atoms of carbon here. So we add 6 to this place. We end up with 6 atoms of carbon, 12 atoms of oxygen. Right here we have just one here that is altogether 13. Here we have 6 atoms of oxygen, and right here we have +2, which is 8. So here we have you have 12 here plus 1, that makes it 13. So what do? Right here we have 12 atoms of hydrogen. You can add 6 to this place to make it 12 atoms of hydrogen, 12 atoms of hydrogen. So that means you have oxygen here 12 plus this 18. You add 6 to this place also to make it become balanced. So as you can see, this very chemical equation is balanced. So how do we show that this obeys the law of chemical combination? Now don't forget, according to the law of chemical combination, all the elements that come together, that react together in the reactant, maintain their quantity in the product side. So let's explain that using the relative molecular mass of each of this stuff that we have here. So let's get to know the atomic mass unit for each of them. Carbon is 12, oxygen is 16, hydrogen is 1. That's what we have, so we're going to be using this. So first we're going to get the relative molecular mass of each of this reactant. So after you're done with that, then we get the total relative molecular mass for all the reactant. Then we're going to compare with the total relative molecular mass for all the product. Now, if we get the same atomic relative molecular masses for the two sides, that's for the product and for the reactant and for the product, it means this law is being obeyed. So let's check that out. So first, carbon, 1 atom of carbon here alongside the 6. We have 6 atoms of carbon altogether. That will be 6 times 12. Then plus oxygen here is 12 altogether. 2 atoms, and 2 times 6 is 12. That's 12 times 16 altogether. So that's that for the carbon dioxide. Then next, the water, hydrogen here is 12. 2 times 6 is 12. So that's 1 times 12. Then plus oxygen here is 1. 1 times 6 is 6 times 16. So we are done with that for H2O. Then let's start working on the product side. Now for the product side, carbon is 6 atoms, that's 6. Carbon itself is 12, 6 times 12. Then plus hydrogen is 12, 12 times 1. Plus oxygen is 6, 6 times 16. Altogether, we are done with the glucose. Then plus oxygen here is 12 altogether, 12 times 16. So let's work on this. So what they are, 6 times 12 is 72, plus 12 times 16 is 192. Then plus, the 1 times 12 is 12. 6 times 16 is 96. And equals to 12 times 6 here is 72. 12 times 1 is 12. 6 times this is 96 also. And plus 12 times this is 192. So what do we have? Let's add up all this. Now for the CO2, so on the 2 plus 192 will give us 264, plus 12 plus this will give us 108. Then we're going to add this up. So on the 2 plus this will give us 84. 84 plus this will give us 180 plus 192. So it's high time we added all this up. So we're going to add up the atomic mass units for the reactants and also going to add up the atomic mass units for the product. So 264 plus 108, let's do that simple math. 108 plus 264, that's 12. That's 7, this is 372 AMU, atomic mass unit. Then the same thing for this 180 plus 192 will give us 372 AMU. So it means these very this very equation here, this photosynthetic equation, let me use that word, obeys the law of conservation of matter. Now, how do you get to know that? All the reactants here, the summation of the masses of the reactant here, is the same thing as the summation of the masses of the product. It means none of this reactant here, as per their constituent, changed in the final product. It means this law is obeyed as simple as ABC. So I'd love you to stay tuned for more example on this.